Hello, everyone. So today we're going to do domains. So I can identify the domain of a function algebraically, graphically, and in context by finding values where the function is defined. So the domain of a function is all the possible inputs of the function, or you can think about it as all the x values that it goes through. Okay. It is written in interval notation from least to greatest. Sometimes it is also written in inequality, but we're going to focus on interval notation this year. And if so, here and there during the lesson, I might show you how it looks inequality-ish because that helps you for the mathematics, okay? So algebraically, we want to look for things that cannot happen. So in other words, I always ask right away, is there something wrong with the function or that you don't like about the function? And our two issues or two functions is that it cannot be divided by 0. So you got to think of those rational functions. Okay, and it cannot, the square roots can be negatives, right? We can't take the square root of a negative number, right? Now, the other thing I want you to keep in mind, though, is it's just not square roots. It's any even root. Okay, any even root. So what we're going to do is when we see any even root, we're going to take what's under the square root. Let's just say it's a. Let's get rid of that negative. And set that equal or greater than or equal to 0, right? And in the rational, the denominator cannot equal 0. Okay, so let's do some examples. Find the domain of f of x. So we have 4x plus 1 over x minus 5. Again, I always ask myself, do we have an issue with this? And my answer would be yes, we have an issue because it's a rational function. So in that case, our denominator cannot equal 0. So we take our denominator, set that not equal to 0, and solve. So x cannot be 5. Now, if we were doing inequality notation, we could leave it just like that. We're all done. But because we want to do both, and specifically interval notation, that means that we would have negative infinity to 5 and 5 to infinity because it cannot be 5. The reason why this is not 5 is because of these parentheses. Parentheses means that they don't touch. It's like they skip, just like in this number line here. There is a hole around 5. Okay. Brackets make it hit, and you'll see something like that when we come to a square root, which is our next example. Okay, so again, I look at this function and I say, hey, is there an issue with this function? And you say, yes, there's an even root in there. Since there's an even root, I know what's under that square root cannot be a negative number. So all we do is we take what's under that square root or even root, okay, and we say greater than or equal to 0, and then we solve, okay? So in this case, we're subtracting both sides by 2. Now, again, this is inequality notation, so that's pretty nice. But if I were to do this in interval notation, well, x is greater than -2. What type of numbers are greater than -2? Well, that's all the way to infinity. So we start at -2 and we go to infinity. Now, because it can be -2, it's equal to, it has to be a bracket. So be careful about your brackets and your parentheses. And hopefully you're remembering that parentheses are around infinity and negative infinity. All right, next page. Okay, let's see what examples we can do on our own here. So, A, we have this function. Is there an issue with this function? Yes, there is. It's irrational. So we need to focus on the denominator because we know the denominator cannot equal 0. Okay. At this point, there's an x squared in there and an x, so I know I'm going to have to factor. I'm going to factor quickly. You factor how you need to. So this becomes x minus 4 times x plus 2 cannot equal 0. So what makes each of these 0? So x cannot equal 4 and x cannot equal -2. Now, if we were to write this in interval notation, you want to make sure that you are going left to right in your number line. So what number do we always say is all the way to the left? Well, that would be -infinity. And then what we do is we say, which one would come next? It'd be -2. Now it's not equal to -2, so we have parentheses there. And we start back up at -2. Again, not equaling, right? So parentheses. And then our next number is 4. Start back up at 4. And of course, what number is all the way to the right? Infinity. Now, I will point out that most people, when they do this, if they do it really fast, this is where they mess up. They forget about this interval. So be careful on that. B, if I look at this function right here, are there any problems with this function? Hopefully you're saying no, because it's not rational and it's not an even root. So when there is no problem with the function, your domain is -infinity to infinity. And you're done. Now you're going to have to recognize those. All right, see here. Is there any problem with this function? Yes, it's an even root. It's a square root. So remember, we take what we have under the square root, only what's under the square root, so not that one, set it greater than or equal to 0 and start solving. So I'm going to subtract 3 from both sides. Get -2x is greater than or equal to -3. Now we did this example on purpose because what do we do here? Get x by itself, we divide by -2. But what happens when we divide by a negative number? We switch the sign. So that's one thing we need to remember when solving inequalities there. Now, this is where we go back. I know I have an endpoint of 3/2. The question is our values going to be to the left or to the right? Like on the other page, it was greater than the value, so it went to the value to infinity. But here, x is less than, so smaller. So what types of values are smaller than 3/2? Hopefully you said negatives and -infinity. Now remember, parentheses are always around infinity or -infinity. And because it's equal to, this is going to be a bracket. All right, so those are your things that you want to do algebraically. Now let's look at it graphically. So when we look at it graphically, what I want you to do is always look left to right. Okay, I look at this number line here. So as you can see in this one, we have an issue right here, right? Because we always talk about issues, right? We have an issue right here. Because what are those called? We did this a couple lessons ago. Those are vertical asymptotes. So what I like doing under the graphs is I like putting my domain because it's right there for me. So I start at -infinity because there's an arrow there. And I'm going all the way to -4, but then it doesn't touch -4. So that's why it's a parenthesis. Then we start back up at -4 and go to 2, right? That's that vertical asymptote. And start back up to 2 and go to infinity, and then we're done. Infinity because of that arrow. Now, with this graph, I'm going to add on to it. I want you to do 2. This is an arrow. This is a point that's filled in. Okay. So when we talk about domain, remember everything to the left. So if you look, this left tells you you're continuing left. So what's the farthest we can go left? -infinity. Well, as we go to the right, where does it stop? It stops at 4. You guys see that? It stops at 4. Don't look at the 2. The 2 is the y value. We're only looking at the x values for domain. And then it's a filled in circle. So that is a bracket. Of course, that's our square root right there. It's just flipped. Let's check this one. Okay, I'm going to add arrows to this, right? So if we talk about left, this arrow, even though it's pointing down, it also continues all the way to the left. So what number is all the way to the left? Negative infinity. And as you can see, it go up, down, no issues, right? And that arrow continues up, but also to the right. So negative infinity to infinity. Again, no issues. It's a cubic. It is not a square root. It is not irrational. It's a cubic. It's an x cubed. And there are no issues with that. So negative infinity to infinity. Now let's go to piecewise. First of all, why do they call it piecewise? Well, they call it piecewise because this graph is in pieces. Okay. And then these are the functions. So this is where you could do it algebraically. This is where you could do it graphically. So we're going to talk about domain right now because in the future, you're actually going to learn how to graph these. Okay, so let's do it by the graph because it's so much easier to do it by the graph. Okay, so I'm going to go left to right. So we have an issue here, right? Because it's open. There's no fill right there. Oh, sorry, guys. Let me get the light on. Now, so we have an issue right here, right? See, because there's no fill. Where here, do we really have an issue right here? Because this is open, but yet this is closed. So since this hits at that X value, we're okay. Then we stop here and we don't start up until right here. Do you guys see that? So our issues are right here, and right here. All right, so if I were to write these inequalities, since I wrote my little segments up here, I'm going to write it up here. So that arrow tells me negative infinity because it keeps going, and then go all the way to this number. What is it? 1, 2, 3, 4, negative 4. Now it is open, so it needs to be a parenthesis. Then I'm going to start right back there. And I'm going to go all the way. And as you can see, there's no issue until right here, right? So what value is this? We go 1, 2, 3, 4, 5. So negative 4 to 5. Now it's filled in. So that is a bracket. Now, as you can see right here, there's a gap. So I'm going to write this in gap. So because there's a gap, I'm not starting back up at 5 because nothing is happening from 5 to 7. Do you guys see how there is no lines between 5 and 7 here? So that means we start back up at 7 and it's a bracket because it's filled in, and we go all the way to that arrow tells me infinity. Parentheses around the infinity. Now, sometimes teachers are picky, and when you have multiple intervals like this, they want you to put what's called a union in between them all. So it depends on your teacher if you're going to be picky about it or not, or the computer system. All right, so this is how to do piecewise. Let's see, are we done with the packet? We are done with the packet. So let's see how you do on some of the practice.